Hi guys, Dr. Orlando here with a video on incomplete dominance. This should be a quick one here. Just want to describe this pattern of inheritance that you see sometimes in genes. And a great example to use are these snapdragon plants. And snapdragons come in different colors, and they are they follow incomplete dominance with respect to their flower color. So with snapdragons, with these plants, we have red, which is going to be our capital R. And that capital R tells us, when we use the capital letters, we know that that means that it's dominant. In this case, red is dominant. Okay? But there's also white plants, and the white plants are little letter R. And that is the recessive. And it's you only see a white plant if the genotype is homozygous, right? Little r, little r. So those are the possibilities. You're red or you're white for the parent plants here. But it turns out there's a third possibility. Pink. What? How'd that happen? All right, so let's have a look at this. If a parent plant is red, it must be homozygous dominant. Okay, this is different than when we look at our simple Mendelian traits. In this case, if a plant is red with incomplete dominance, it has to have both alleles be capital R's. Okay? If a plant is to be white, it has to be a little r, little r. Okay? And that is a white plant. So then, when we see the big R, little r, we get a pink plant. So the heterozygous genotype, which is the big R, little r, is a third phenotype. Okay, we don't just have red and white plants, we got red, white, and pink. Okay, so let's have a look at, let's fill these in there completely. Big R, little r, and big R, little r. Let's do a little scenario here on these. Okay, so let's say you want to plant some flowers in front of your house, and you've got snapdragons. And you went to the store and you bought red snapdragons and white snapdragons. Whoop. Okay, so you've got red snapdragons and white snapdragons, and you planted them alternately, red, white, red, white, red, white, and they look so cute in front of your house. Okay, so then you take those plants grow, they make their flowers, they make their seeds, and they happen to cross-pollinate. Okay, and if they cross-pollinate, what's going to happen? What would their offspring look like? What would the seeds that those plants make look like? Okay, so let's draw a Punnett square here. Okay, so over there. So the red parent can offer its offspring, capital R or capital R. The white parent can offer little r or little r. So all of the offspring, all of the seeds made by these two plants cross-pollinating are going to be pink. Do you know that right away when you see those seeds being made? No. What do you got to do? Those seeds have to be planted. So there you are. Your plants have died back for the winter, and next spring comes, and you go thinking you're going to go buy some more snapdragons, and you notice that there are snapdragons already coming up. You think, oh, my plants are coming back. That's great. Well, maybe they're not coming back. Maybe what happened is we made seeds, and those seeds are what are growing. So you see, you look, and you go, wow, all my plants are pink. I don't have red and white like I used to. All the plants are pink. This would be our F1 generation This would be our parent generation. Okay. So first year you get red and white. Second year now all the new plants are pink. And you think, well, pink's not so bad. So let's just let that go. So next year, what happens? So now these are all the plants that are planted in your flower bed. They're all pink. So those are going to cross-pollinate and make seeds, right? So what do you get? Make it pink because the parents are pink, I guess. So the parents are, in this generation, the parents are big R, little r, crossed with big R, little r. So this is one parent. This is another parent. So go ahead and fill out that Punnett square. And what do you get? Oh boy, we get quite a mix. Well, let's see. 1/4 of the plants are going to be red, and their phenotype is red, and their genotype is capital RR. And then 1/2 are going to be pink. Their genotype is capital R, small r. And then also 1/4 of them will be white, little r, little r. Okay. So now this third year, and these will be your F2s. Okay, this third year in your flower bed, you have red, pinks, and whites. All right, very cool. And what happens the following year? Well, there are many possibilities, right? If these two, if we go to fourth year, if these two cross-pollinate, all of the offspring will be pink. If these two cross-pollinate, we could get a mix of reds and pinks. These two cross-pollinate, we can get a mix of reds and whites. Okay, so you're going to end up with, on the fourth year, all sorts of craziness in different colors. So that's what we call incomplete dominance, where the heterozygote is a blend of the dominant and recessive traits. If you have any questions, please feel free to contact me.